Welcome back to College Algebra, MAT 150. In this lecture, we will discuss vertical and horizontal lines and the average rate of change. So for vertical lines and horizontal lines, we have the following sort of equivalencies. So if you think of one, you should think of the other. So if you see x equals a number, this indicates a vertical line, again vertical meaning up and down, and it always has an undefined slope. Or if you see undefined slope, you know it's a vertical line equals a number, or vertical line, you know one of these two. So if you see any one of these three things, you should know the other two is also the case. For horizontal lines, again, that's going left and right. It always has a slope of 0, and it's always given by y equals a number. So x equals a number is a vertical line, and a y equals a number is a horizontal line. So if we look at this, graph the following. So if you see y equals 3, all you do is go up to 3, and it's a horizontal line. So y equals a number, horizontal line. Again, doesn't have to be perfect. X equals -2. That is a vertical line. So you go to -2 on the x-axis, and you just make a vertical line. Again, does not have to be perfect. My advice is usually to label your graphs. I didn't do that so much in the last video. But especially here, you might be able to see if you have a y-axis and an x-axis, how do I know that this is not the axis and this is? Well, because I labeled this as the x and y-axis. And I labeled this as y equals 3 for a line. Similarly here. Okay? The other thing we want to talk about in this lecture is the thing called the average rate of change. And it should look familiar. y2 minus y1 over x2 minus x1 equals m. Well, that's just the slope. But if you have a function that's not necessarily linear, you can talk about how the average rate of change between one point and another if it's not a line itself. And notice that this says y2 over x2, this represents x2, y2 is a point, x1, y1 is a point. x2, f of x2, and where f of x2 is the y value there, so this represents 1 point. x1, f of x1 represents 1 point. And again, it's called the average rate of change. So for example, if we saw this, the number of people participating in the Federal Supplemental Nutritional Assistance Program has increased from 17.2 million in 2000 to 47.6 million in 2013. We want to find the average rate of change, so just slope, in the number of people using food stamps from 2000 to 2013. Well, we can think about these data sets as kind of points. So if you look, it says it was 17.2 million people in 2000. So if we think about points as being x, y, and x being the year, and y being the number of people participating in the program in that year, then we have 2 points. So in 2000 I have 2000, and in the year 2000 we had 17.2 million. So written out, that looks like this. And in the year 2013 we have 47.6 million. So we have these two data sets and the slope. So we're talking about where it finishes. So we do, in this case, it does matter which one we're picking first. So we want to talk about how many people, the average rate of change in the number of people using it from 2000 to 2013. So we definitely want to use the second one first. So y over x. 47,600,000, excuse me, over 2013. Again, just from the slope formula, the y over the x minus minus the y over the x. So 17,200,000 over the year 2000 is our y. And then 47,600,000 minus 17,200,000 is 30,400,000. And 2013 minus 2000 is just 13. And if we wanted to get a more precise number, we should actually probably simplify this fraction, so at least to a decimal. 30,400,000 divided by 13 yields 2,338,461, about. So we'll put an approximation sign there. We have 2,338,461 people. People increase. From 2000 to 2013. This concludes everything from this lecture of 1.3 Part 3.